Hello guys, welcome back to another episode and video of Math Made Easy, where I'll be continuing on quadratic and fractional equations of the Sec 3 emath syllabus, and we're going to cover how to solve quadratic equations in one variable using the quadratic formula. Now, there are two parts to this. First, I'll give you a basic understanding of how the formula actually came about, and from there, how we can apply that formula when solving quadratic equations. So if you just want to jump straight into how the formula is applied, you can head on to this timestamp over here. Otherwise, it is not important that you learn how the formula came about. It's not tested for your exams. So without further ado, let's begin. So how we are going to solve quadratic equations using the formula. So as you remember, in completing the square in the specific equation or a specific variable, let's say we have x squared plus 4x minus 3 equals to 0. Well, you would tell me that you would group x and 4x together and bring the 3 to the other side. Then you would say, let me get my 2x plus x minus 3 equals to 0 and continue solving from there. Well, what if we can come up with a general formula to find x? Because remember, when we are solving an equation, all we are doing is trying to find x. So we're just trying to find that missing variable. So if we can find a formula that finds x regardless of whatever values these may be, the coefficients of x may be, then wouldn't that be so much easier? Exactly. So that's how the formula came about. And it is a simple way to get the formula and the answer to equations that may not have such a perfect number like 3 or 4. And it is also a easier way to solve quadratic equations without having to do the cross method or the multiplication tables. So let me show you the proof. So let's take a general quadratic equation. Ax squared plus bx plus c, as all of you might know, equals to 0. Now, remember in completing the square, we remove coefficient of x squared, which means we divide everything by a. So we get b a of x plus c a. Now the reason why I'm telling you the proof is so that when you actually do the formula, you won't have to memorize the formula, but instead understand of how the formula actually came about. And next up, after removing the coefficient from x, let's bring the constant term to the right hand side. And from there we get x squared plus bax equals to negative c over a. All we are doing is bringing the constant term to the other side. Now, we want to get x on the left hand side equals to a certain value. So how do we do that? Well, if you remember from the completing the square, instead of what most of you might do, which is factorize this into x plus b over a, you get two x's here, which is very hard and complicated to deal with. Well, instead we can use what we've learned in completing the square and instead turn this into a x plus r squared equation or expression. So from there, we will turn x squared plus b over ax equals to x squared plus b over ax plus b over 2a squared. And remember, when we add something, we also need to minus and take it from the right hand side. So if you add something from the left hand side, we need to subtract it from the right hand side. So that will give us plus, or you can write it on the same side. So it's just bax plus b over 2a squared minus b over 2a squared equals to ca. This is essentially our b over 2 squared. So you can either do a addition of both sides, or you can do an addition and subtraction on the same side of the equation, as long as the left hand side equals to right hand side, then it will be okay. Now we have the b squared minus the b over 2 squared expression in our equation. So now we have the larger form, and now we can factorize it, remember, as I said in my previous video. So from here we can change it into x plus b 2a squared, removing this x term entirely. So that makes life a lot easier for us. And from there we can turn the right hand side into minus ca plus b 2a squared. Oh, I'm continuing from this step, if you can tell. And from here, we can change this expression into b squared minus 4ac over 4a squared. If you expand and simplify the equation, you will get this. Now, remember there's a square here. So what did we learn earlier? If there is a square here, we just bring the square over to the other side. And that's what we are going to do. We get x plus b2a equals to the square root of b squared minus 4ac over 4a squared. Now remember, when we have a square root, we need to add the plus and minus to accommodate for the positive and the negative values of the answer. Now, from here, to find x alone, what do? We just bring b over 2a to the other side. And from there, we get x equals to b squared minus 4ac over 4a squared minus 2b over 2a. And from there, if you combine the expressions together, you will get minus b, let me make it clearer. You will get minus b plus minus b squared minus 4ac over 2a. How I might get that, you may ask? Well, let's simplify this expression first. We get plus minus b squared minus 4ac over plus minus 4a squared minus 2 minus b over 2a. Yeah. So what we're doing is when we are square rooting a fraction, the square root goes on the numerator and the denominator. So we need to accommodate for both of them. Now, what can we simplify here? See? Square root of 4 and a squared. Square root of 4 is 2. Square root of a squared is a. And that's how we get 2a over here. Since the numerator cannot be simplified, we just write it as it is with the plus and minus. And after combining the fractions together, we get this equation over here. I hope that is easy to understand. Now, this is the formula for x. If you want to find x, this is the formula. So you don't have to solve with multiplication tables, your calculator, cross multiplication, whatever. You can have a one formula that does everything for you to make your life easier. So remember this. However, there's a caveat here. The only caveat is that a cannot equal 0. Why? Because you cannot take anything divided by 0. You cannot take 1 divided by 0. You cannot take 2 divided by 0. You cannot take pi divided by 0. Anything divided by 0 is undefined. And see, the denominator is 2a. Which means if a is 0, denominator will be 0. And that's why it cannot work. So that's it. Oh yeah, when we say the formula is minus b plus minus b squared minus 4ac over 2a, there are 3 different types of scenarios we need to look out for. Number 1 is when the certain terms give us different values, which in this case is this, because it can be positive, it can be negative, or it can be undefined. And that we don't really know. So it can either be a positive value, a negative value, or undefined. You just need to know these three options that you may have when solving the equations, which we'll get to in future videos. So that's all for this video. Hope you understand and you can use the equation.